Like so, with name2, then you could use, if name2 I haven't instantiated, you say something like equals new. Equals new. You could say name2 arrow. Because you have the pointer to name2. If the pointer, you want to use the arrow. If it's not a pointer, you want to use the dot. The other part of this, though, is if you have a pointer, I'll go to the other side of the room real quick. If you have a pointer to an array, so for example, I say item star stuff equals new item of size 10, like so. So I have an array of items. Even though this is still a pointer, this is an array of items as opposed to a single one. If you use stuff as an array, you want to use the dot, because the stuff of 0 is the object, not a pointer to the object. Yes?
So the arrow is just a dereference.
Correct. So the arrow is equivalent to the star in parentheses with the variable name dot, because this is equivalent to that as well. Good question. Good answer.
Good answer.
Good answer. But he had a good response to the arrow is essentially a dereference and a dot, which is exactly what it is. Okay, number 1. When discussing variables and values, we often talk about using the correct type. What is a data type? Yeah. So types tell the compiler and the CPU how to interpret the ones and the zeros. When we define new classes, we're defining new types, and those new types that we're defining is we're telling the compiler how to organize all the ones and the zeros. That's all we're doing. Once those ones and zeros are organized in a specific way, we then tell it which functions can be called on those ones and those zeros such that operations can be performed. When you think about the fact that you have an integer, for example, you say int x equals 3, that int is telling the compiler that x can have the addition operator assigned to it, which is different than, for example, in Java. So if you're looking at, say, Java, and I said int x equals 3 versus string y equals hello. If I say x equals x plus 2 versus y equals y plus 2, this operator here is the addition for the x, whereas what's the operator down here? Concatenation. And how does the compiler know that? Because it knows the type of y and the type of x. The type of y is a string, which makes the plus sign a concatenation operator, whereas x is an integer, which makes the plus sign an addition operator. Right? And so that's why it's telling the compiler and the CPU how to interpret the ones and the zeros. For example, we talked about the h as being an ASCII character. Those are ones and zeros. How do we interpret those ones and zeros? Well, in this case, we're interpreting it as concatenation versus otherwise. That's the best answer out of all those. Number A is patently false. You can store anything that can be converted to binary in a computer. Typically, the difficulty is figuring out how to store it in binary. When we talk about doing things in three-dimensional space, oftentimes what we do is we store things as three-dimensional points, and then many three-dimensional points, or math functions that define the merging or the connection of two three-dimensional points. But it's not necessarily like, we're not actually storing, like if this water bottle, I don't know if this is ours, but if this water bottle, if we wanted to render it in a computer, it's not actually a water bottle, it's just a collection of points, right? But it's still a representation of it. B is not true for any of the languages that we've used so far, but it does work in some languages. Some languages do split up where they store things based upon the types. Strings, for example, particularly literal strings, like the word hello here, are stored in special locations in almost all the languages. So why this is kind of true, this isn't the point of it. It's just a byproduct of knowing these things. And organize the code better may or may not be true depending upon whether or not you know how to program without types. For example, there are many Python developers who don't use types that way to organize their code at all. Any other questions about number 1? Number 2, all programming languages share the same fundamental types.
False.
It's false. So for example, Java has several fundamental data types: int, float, double, character. What other ones are there? Boolean.
String.
String is not a fundamental type in Java.
Double.
Long, I don't remember. There's a couple more. Long, short, yeah. And then in C, for example, there's another set of them. In C++, there's another set. In C++ and C, for example, pointers are fundamental data types. They're not any different, whereas there are no pointers in Java. If we talk about Lua, which we talked about a little bit, we know that numbers in Lua are both integers and floats. There's no difference between those, and that's a fundamental data type in Lua. So no, the answer is false. 3. Defining a class in an object-oriented language does what? Yeah. Which one's correct?
A.
A is the correct one. I know many of you have not read all of them yet, so it's a little bit difficult, but A is the right answer. Here, let me bring it up a little bit higher. Let me see if I make it just a touch bigger. See how the screen jumping just slightly there? So why is A correct? And instead of why is A correct, why is B false? Or not necessarily false, but less correct. You have a guess?
There are the objects predefined.
That's-
So you don't have to define a class to create an object.
That's true. But so it implements the basic functionality for object-oriented programming to work, is B here, right?
What about B?
Huh?
B.
D?
B.
B?
As in boy.
As in boy, yeah.
Requires thinking primarily in terms of actions, whereas C++ is also.
See, thinking in terms of things, that's a really good way to do it. But why is 3B incorrect? Is the question that I want. Is the question I want to know. That doesn't answer it, and yours doesn't answer it either.
Oh, I'm looking at the wrong question.
That's okay.
Yeah, I'm ahead of it.
Excellent. No, good job. Do we have a guess?
We were able to kind of use the basic functionality of object-oriented programming with structs and not classes in C.
So this goes back to what is object-oriented programming? What is the functionality object-oriented programming gives you? Inheritance, polymorphism, protection mechanisms. Those are the basic functionalities that they have. Did we use any of those in C? No. But we kind of got the same concept of thingness with structs. And we know that we can build have functions inside of structs. And so really, when we talk about object-oriented programming, we're talking about those three mechanics primarily. Now, when you define a class, do you implement any of those three mechanics? No. Those three mechanics are implemented by what? In the case of Java, in the case of C++. No. Say it again? The compiler implements those three pieces of functionality. So for example, when you say class blah 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 with an overloaded method and inheritance and things like that, the Java compiler is the part of the program that, or is the part of Java that understands object-oriented programming and gives you those three methods, those three pieces of functionality. Same thing is true for C++. The compiler is what knows these things. Now, the reason why C does not have object-oriented programming is why? No? There's a very mundane answer to this. Huh? No. Object-oriented programming was invented before C was. Yeah. No. That's a byproduct of this. But why does C not implement why does C not have object-oriented programming? Because the compiler doesn't implement object-oriented programming. Right? I told you it's a very mundane answer. It's like one of those things you're like, oh, okay, yeah. Kind of a stupid answer. So why does C++ have it? Because the compiler implements it. One of the things is when we get into Lua, the Lua interpreter will not implement object-oriented programming for us. What we're going to have to do is we're going to have to implement object-oriented programming ourselves, and we'll learn how to do that. C specifies where certain memory. D allows program developers to work in groups and large projects. Is that what defining a class does? No. Object-oriented programming allows you to do that. That's those other mechanisms we were talking about, not defining the class. 4. How is C different C++? Ivan?
Oh, sorry. I said C requires thinking primarily in terms of actions, whereas C++ allows us to think in terms of things.
Yeah, that's probably the best answer. So for example, A is incorrect because both C and C++ have pointers, and we have to both understand the pointers of both of them. C requires us to think in terms of things, whereas C does not let us think in terms of things, which is not true. We actually figured out with C that structs allowed us to think in terms of things. C is a subset of C++, and this C does not contain everything C++ does. While that is true, that's the wrong way you want to think about that. C is the original, and C++ is a superset of it that implements more things. It's really the way that it goes. It's not that C is a subset. We didn't invent C++ first and then make C later. We started with C and we came up with C++ after. One of the first languages to implement object-oriented programming is a language called Smalltalk. It was invented in the 70s, I believe, to teach children how to program. And so we had kids making adventure games in Smalltalk in the 70s and the 80s, before C even existed. Lisp is another language that came out of that generation, where Lisp is another object-oriented programming language. Lisp also happens to be functional, which is something that we haven't really talked about how to do, which makes things very strange. Again, it's one of those things that if you think about programming from a novice's perspective, functional programming makes much more sense than anything we've done for the first year and a half that you've been with us. And so it's going to be another one of those languages that we're going to take you and kind of go, everything we taught you was wrong, except for it's absolutely correct, because functional languages are almost impossible to make large projects out of. If you want to build things like Facebook, you can't use a functional language. However, if you want to build something like Facebook, you can't do it without a functional language. So you're kind of stuck between a rock and a hard place. The way Google works is a functional programming technique. The way Facebook works at the large scale is functional programming techniques. However, the languages themselves don't implement the structures that allow the rest of the system to work. Like we talked about the Facebook web page and how all those different parts interact. Trying to do that functionally would be nauseatingly difficult. Whereas the languages we have to do it are relatively simple by comparison. All right, let's move on. What is the purpose of a shell scripting language? A, B, C, D. Which one? So C, controlling remote servers automatically, is hacking into people's accounts and stealing information. Yeah, that's what we did, right? But that's not the purpose of scripting languages. Controlling remote servers, did we do that a little bit? Yeah, we did that, but that's not the purpose of it. Running large applications without human interaction? No. A is the right answer. So scripting languages are not typically about running large applications. It's about running smaller applications in concert to create a larger application field or to solve larger problems. That was really what all the scripting language stuff we did. Number 6, shell scripting languages only run on Unix, Linux, and BSD machines. False. OS 10 runs Bash natively. Actually, OS 10 is a BSD. So when we say BSD here, that's what OS 10 is. It's not technically Linux. It's BSD. They're a little bit different. Windows also has a shell, which is the terminal. You can also download something called PowerShell for Windows, which is a more powerful version. It's also just called PowerShell. Number 7, why would an organization choose to write an application in Java? W? What? Say that again?
Portability.
Portability. I thought you were saying W, and I was like, there's no W. Portability is part of it, yeah? Do we have portability on here? Yeah, portability. But then C, it also has a large number of libraries that simplify many tasks. That's also true. And it's capable of implementing very large software projects because of its design features. What are its design features that allow it to be capable of implementing very large software projects? Huh? OOP, object-oriented programming, right? So inheritance, polymorphism, protection mechanisms, those kind of things. So we know these things. All these things are things, some of not necessarily to a full extent. We know all these things, right? It's just being able to experience them in a different light, perhaps. Like, for example, this one, this question, we should know all these answers. This should have been stuff we knew after 107. But maybe not putting them into the context in which they were I'm asking them here. C++ and Java are different how? So I would say the answer is D, none of the above. All the rest of those things are generally true in the sense that the opposite of what they say is generally true. They both share the same flavor of object-oriented programming. They're both very generally the same fundamental data types. I mean, they are a little bit different. Chars and strings are a little bit different, but such is life, everything a little bit different. C++ and Java, they have the same development paradigms, which is object-oriented programming, classes, and inheritance and whatnot. Any other questions about 9 or 8? Why do most languages prevent you from accessing variables declared in other functions?
Oh, scope.
Is D the answer because it's the longest one?
Oh, yeah.
Is B the answer because it's the shortest one? Let's go through the ones that I think we can verify are not correct to start with. Which one do we know is not right?
B.
A and B. All right, so why? Let's start with B. Why is B not correct? Memory will always exist. Simply because you're not looking at it doesn't mean that it's not there. It's kind of like if I turn around, that door is still there. Because memory is a physical thing that exists. It doesn't just cease to exist. This is also true when you lose pointers. Like if you mid-change a pointer, the thing that you pointed to before doesn't cease to exist. Just because I go like this doesn't mean Francisco ceases to exist. Right? It would be kind of neat if we could do that. Just like point at someone and point somewhere else, that person disappeared.
Oh, thanks. Gone.
I would have been gone a long time ago, don't worry about it. The compiler cannot find variables when they are out of scope. Is that true? Do you think that we can't write a compiler that can keep track of all the variables? No, I mean, we could definitely do that. It's just that we don't want to. And that's really what the question is asking, is not that we can't do it, it's that we don't want to do it. There's a specific reason for it. So what's that specific reason? What does C say? Oh, is C true? What's the biggest worry about things in C that we have to do when we first create a variable? It's so the memory value, we have to do what with it? We have to clear it out, right? What's in it otherwise? Garbage. Because compilers typically don't insert code that frees out that memory, right? If compilers did, like Java actually does. Java does actually insert code that clears out variables' memories for you. Most languages don't. If you just declare a variable, you just get garbage. Why? Because that's what was there before, because it doesn't automatically clear it out. Which leaves D as the correct answer. A variable's value is typically placed on the stack, and when a function finishes, the stack changes, resulting in the value of the memory no longer being saved for that variable, which means it might be used for something else. That is the correct answer. You want me to explain that any more than I already have in that sentence? Right? So when the function returns and the stack goes down, we have this memory. It doesn't cease to exist. It's still there. It's just nothing happens to be using it. Which means that if another function is called, it'll be used for something else. That's really what this is talking about. We don't know if it's being used for something else. We don't even know if it had been used for something else. Printf, when you call printf, maybe printf put some other value in there. You don't know until afterwards or later. The answer number 10?
C.
C is a good answer. I like C. A is also a good answer if you chose it. I would give you full credit for either answer. Yeah.
What exactly is
10? 10 is some garbage I wrote there and I forgot to fix. I forgot to go back and rewrite it. It's a, what is scope? So we don't define scope with curly brackets in Bash. I don't know if that was you guys heard. What do you guys? What is scope?
Their working area.
That's a good, so when you say the working area, you mean like where the variables are valid, and it's kind of like when you change scope, you go to a different work area? If you're thinking like, if this is your tool bench and I'm working here, I have all these variables access to me. If I go over here, I have a different set of variables that have access to me. That's a pretty good answer. Is there another way we could say that though? I like that answer, that's a very intuitive answer. How about a region in which a variable's memory is accessible by a name, or its variable name? It's essentially the same thing you just said with more words. Doesn't necessarily mean it's more correct. Anyone else have answers or questions about number 1? So scope is the region in which a variable's memory can be accessed by that variable's name. It's the region in which a variable's memory may be accessed by that variable's name. So we're going to do something real quick here to talk about this scope to drive this point home. So this is a relatively basic function. It doesn't work. It will just result in infinite recursion that would crash eventually. Foo of x returns foo of x plus 1. So it'll just count forever, essentially. Not something that we particularly want. However, it is illustrative of what we're talking about. So this integer x is a parameter. Where does that integer x go? On the stack. That is the correct answer. So all parameters and our function variables typically go on the stack. That's the way we want to conceptualize this. We have to remember that not all languages do this, but the conceptual nature allows us to think about it that way. So if we're thinking about this as being our memory, and we have a code section in the middle. So this section in the middle is our code. We typically think about our code being on top of, or our stack being on top of our code and growing up towards the top of towards 0 on our memory here. If we run over 0, it's a stack overflow and our program will crash. Other operating systems, for example, Windows puts it up the top and it grows down into the code, which is part of the reason why stack overflows in Windows are particularly nasty. Because when you have a stack overflow this way, you would get inside of the code. But our stack grows like so. So for example, if we call foo of 3, we get an x on our stack, which has the value of 3. Right? What's that going to do? It's going to call foo of 4, which means we're going to get another x on the stack here. We're going to put the 4 there. How many times do we have x on the stack? We have 2 versions of this x. And then when I come into the next one here, I create another that foo of 4. When I go to call the next foo, which value of x do I use when I say x plus 1? The 4. I don't call the 3 because the 4 is the most recent one. So even though I have this x, the scope for this x is that memory location. Even though there's 2 of them that it has potential access to, the scope for this variable named x is that location. Does that make sense? So as this, let's suppose that this function magically worked and then it called back down and it finished. When this function finishes, we think about that memory as being erased. Does the memory actually get erased? No, it does not actually get erased. It's just left there. And so we have this kind of phantom 4 sitting there that might be used for something else. As it returns, now we're going to come back here and we're going to go to return. What's the value of x inside of this function when we come back? 3, because the previous scope is now gone off the stack. So as the scope works its way up the stack and as the scope works its way back down the stack, the scope for a variable changes. And that's the reason why we say it's the memory location. So for example, if we have these two memory locations, if this was 3020 and this is 3024, that 32020 is the memory location that that variable was accessible to for that scope. When that scope is gone, now that x refers to that memory location as opposed to the other way around. Some of you are looking at me like, the fuck just happened here? I don't understand. Yeah? All right, so let me do a slightly more complicated one that will actually finish, and we'll take a look at this. Let's make this short. Who can tell me what this function does? Anyone? Returns the difference between x and 3 is what it does. Might not be intuitive to how that happens, but I'll prove it to you in a second. What we're going to do is we're going to start, what's the difference between 3 and 0?
3.
3. So the answer we're going to be looking for is 3. Might return 1 plus it. We'll find out. So I'm going to say foo of 0 here. So when I say foo of 0, what ends up happening is I'm calling foo. When I call foo, memory gets placed on the stack for the function call, like so. Right? Which variable am I allocating memory for? X, which is the parameter there. So this is x. What's the value of x?
0.
0. So now, as I come to this if statement, so now I enter into that if statement to execute that if statement. Which x are we talking about?
0.
This x right here. Let's give this x a memory address. Let's say this is let's say it's 3024. Let's say that's the memory address that x is at. So I'll write some other ones. This is 3020, this is 301C, 3018 as an example. Those are the ones we use. So when I say x equals 3, which x am I referring to? The answer is 3024, right? Because that's what memory address this x is referring to. Because in the current scope, 3024 is x. Does x equal 3? No. So do I do that? No, I go down to the return statement here. The return statement says, what do I do?
Calls foo again.
Foo of x plus 1, right? So what I do is I calling the function again. So I allocate some more memory for the foo function. That variable that I'm saving is the x for that foo function. What is the value of that x?
1.
1, which is because 0 plus 1 gives me 1 here. So now I have that 1. When I come in here now, so I executed this line, and then I came down here and I started to execute this line, right? Well, now I'm coming back up my next stack up, my next iteration up, and I'm looking at this if line again. My next iteration now, yes? The x plus 1 here? On the outside? I have not executed that yet. I've only started by executing this line. I have to know what this is before I can add 1 to it, right? Does that make sense? So if I don't know the value of this, I can't add 1 to it. So now I'm coming here and I say with the purple x equals 3. Which x am I referring to? 3020. That's the scope that we're talking about. So the scope of the variable name is really the memory address that that variable name has access to. Even though I have two locations that could be x, the current scope only refers to one of them, which is the one that's currently highest on the stack. So is that x equal to 3? And the answer is no. So we come down here, we go to execute that guy, right? Which means that we put another x on the stack. And we execute the foo again with the 2 on there. If you come in here a third time, we look inside of there. Does x equal 3? No, because x equals 2. Not 1 or 0, just the 3021C is the one the memory address is allocated to. So we come down here, we come down to this line, we execute this section, which means that we get another x on the stack. And its value is 3, correct? We come in here and we say, hey, where's my pen? We execute this line again. If x equals to 3, does x equal 3? Yes. So do we execute this line?
No.
We execute this line. What does this line say?
Return 1.
Return 1. So we come back here, we return 1. When we return 1, I'm going to erase this pink line off because we're returning. You notice how I still have all these other lines on there? They're not erased because those functions are still executing. They're just waiting for the next foo to finish. And so when that foo finishes, it's going to get rid of this space on the memory. Right? So that stack location disappears. It doesn't really disappear. We just pretend like it's no longer there, and that garbage is still left inside of the memory then. Right? We come back here. What did I return? 1. So my bottommost recursion on my trace is 1. So this 1, what do I add to that 1? 1. So I get 2. So I return 2 off of this guy here, which removes me from the stack. Right? Now I'm at this the purple guy. The purple guy says, what did I return before? 2 plus is 3. So I'm going to return 3. This guy is removed from the stack. Like so. I return 3 here, right? 3 plus 1 is 4, so I would return 4 total. Before I talk about returning the 4, though, what is the value of x here? 0, because the value of x is this one, because all the rest of them have been removed from the stack. So it's the memory location that we're talking about. That's what scope is. This is typically the reason why scope is not global, is because usually we put it on the stack and we refer to these variables as going up on the stack and remembering the memory location. In Lua, this is not going to be true. If you're not very careful about this, this function causes catastrophe in Lua, because you only get 1 x. Alright, bring it back down. More questions about scope? Okay. I know some of you still probably don't have a good grasp on scope yet. Same way we don't have a good grasp on pointers. The only thing I can really say is take solace in the knowledge that you'll figure out eventually. Something else will come along and you'll be like, oh, that's what that means. Something else. So one of the things is I try to do it a couple different ways, but not always works. Number 2. Oh, come on. No. Thank you. Oh. Okay. When and why would you use a shell scripting language? Hack into another server and steal their code? Steal their assignments?
Dealing with string.
That's true. Why would you want to do that?
To automate the processes of a bunch of functions.
Right. So remember, when you're doing all those commands on the shell line, you have to run those commands a bunch of times, and if you can figure out how to make it such that you can automate a large section or a very difficult section, such as finding a piece of text like a password, and then logging into another server, and then figuring out what's on that server, and then taking some of that information, and those are complex tasks. And if you can automate that to be one simple set where you say, go here, do that, that's the point of scripting languages. You want to automate all those systems, which is a combination of smaller functions. But the reason why is automation. Number 3, describe the purpose of pointers.
Share data.
That's one answer. What's the other answer? Correct. What is so? He said. So the first answer was to share data across scopes, right? So you have multiple pointers pointing at the same piece of data. You can say across scope. You can say across programs. Even there's a way that we can do this across programs to be able to share the data between two different programs. If you want to think about it that way. The other one is to have multiple pieces of data pointed at by a single variable name. What's that concept called? Starts with an A. It's 5 letters long. Array. Oh, that's the wrong one. So either one of those answers would have gotten you full credit. Describe the pertinent differences between C++ is new and C is malloc. We didn't cover this one so well in class yet, but perfect time now. Does anyone know the difference?
C++ is new, will allocate just enough memory for the object in question. But with malloc, you can, the programmer has to know exactly how much memory to allocate.
Right. So one of the big differences is malloc needs a number in bytes, and you have to calculate that with the size of it. You don't have to do that with the new. There's another thing that new does that C++ does not do. So what's the difference? So what's the difference between Java's new and C's malloc then? There's another difference then. Let's see it with terms of Java. You already know the answer to this, you just don't realize you do. Huh? So you have to free that in both C and C++. That's true, but that's not the difference here. New does one more thing that that malloc does not. So when you say creates an instance of a class, what does that mean?
You don't have to cast it.
No.
Create the object itself.
What is so you're right, but what does that mean? There's two steps to that.
Assigns the memory to a variable.
That's the assignment operator. I could just have a program that's just full of news. If I did that in C++, if I just had a bunch of mallocs, I'd run out of space and I wouldn't remember any of the pointers. That's fine. Java would do a bunch of garbage collection. There's two steps. The first step is what you said. There's a second step to it. When you're creating an object, what's the second step?
Struct.
Say that again?
Creating a struct.
No. The word you say is super close. That's why I had you repeat it.
Instantiated.
Calls the constructor. That's your constructor. I was like, did you say constructor? No. Calls the constructor. So when you create an object, what are the two steps to create an object? Allocate memory and call the constructor. You guys knew that part, but you didn't know that part together. That's what the constructor is for. That's the big difference between malloc and C and new. Number 5, what language features would you look for when developing a large-scale project, and why? Huh? Portability. So, why do you want portability? So, at a higher level, why? Why do you want that? That's not necessarily true. That's not the reason why you want that. Why do you want that? Why do you want portability?
It could work on the most devices.
Works on the most devices, but why do you want that?
That's work in the future to try
Why do you want that?
To get it to more people.
Why?
More money.
More money for...
Myself.
Well, okay, yeah, that's a good answer. You make more money the more devices it works on for less work. So, for example, if I'm making an application in C++ and I have to write that same application 5 times for 5 different platforms, that's going to take me almost, not nearly, it's going to take me about 3 times as long to develop. Once I have that working on 5 different platforms, then I can make money off those 5 different platforms. If I can develop that application once and sell it to 5 platforms, I'm making more money for less development time, right? What's another language feature? And why would you want it?
Easy to code in.
Sorry?
Easy to code in.
So is that a language feature? Or are there language features that will give you that? Readable syntax. So would you choose Bash for a large... No, why? Because the syntax is kind of shitty, right? Why do you want readable syntax?
So it's easier to follow the
Yes. And so that's the result is you want a readable syntax because it allows your programmers to produce better code or to easier implement.
High abstraction.
Why do you want a high abstraction level?
You get more done in a shorter amount of time.
Good. When would you want a lower abstraction level?
If you're looking with like microprocessors.
So if you're working on something that requires it, and usually your applications aren't necessarily going to do that. If you're making robotics, you have to figure out how to split your application into 2 levels, the low level and the high level. You want your high level to have a high abstraction layer, where your low level might be something in C. You don't want to develop your entire application in C. So we said object-oriented programming over here. I don't remember good. Why would you want object-oriented programming? Why can't I just make lots of little C programs? Huh? Go for it. Well, both of you were talking.
No, I was
So.
saying because you want inheritance
And protection modes. Why do you want those? Right. Why? So you're correct, but why does it make it easier?
I mean, you wouldn't with inheritance. You wouldn't have to rewrite new classes for.
Yeah. So you don't have to. It's code reuse. That's one of the big ones, code reuse, which means that you're making more money because you're spending less time programming. Why do you want access specifiers, protection mechanisms? No, it has nothing to do with that. Any program that's running, you can hack. I'm serious, by the way.
So not just anything.
So not just anything. There's a specific reason why you have access modifiers, and it's not to protect against hackers. So that's part of the reason why we use it. But what's the reason? Why do we have this? It's to prevent other developers from fucking up your code. It's not to prevent hackers from accessing things. It's to prevent other developers from accessing your code. If I got 7 minutes at the end of class today, I'll actually show you. You can access any program that's running on your computer and change any piece of memory that you want. Memory hacking is one of the easiest levels of hacking.
And then making the program modular.
Yes, modularity is a super big part of it with the object-oriented programming. Makes it much simpler to be modular than it is to be in many C programs. Because with C programs, you have to communicate with other C programs. You have to be able to do command line and standard in, right? And maybe a file to standard out, and another program that takes standard in and command line. But that's not really an easy way to make modular programs, as we've learned with Bash. Sometimes it's hard to figure out how to put those together. If you can create a library that has a bunch of functions that another program can call, it's much simpler, and it's much easier with object-oriented. All right, that's good for now. You would have added, I said, if you had come up with 2 features and 2 reasons why, I would have given you full credit. Is this the same question? Almost. Very similar, right? Yeah, just 4 decimal places. This was the question was, were you paying attention to the practice? This was the same question, but a little bit different. You have the dots instead of the arrows. What does this one do?
I have a question.
Yes.
About the one until the same one.
It's almost the same. It's not the same. This one.
No.
You want above? Yeah.
Remember this is not
Did I do something else wrong?
Okay, because it starts at 3.14 and you want to go 4 decimal places, would it be 3.1400?
Correct. Yep. So did you guess at that?
No, I actually worked it out. I actually did it.
You tried it. So did you guess that might have been one of the things that happened before you worked it out?
Yeah, because there was nothing there and you had to fill the space.
Correct. And so that process of guessing, that's the process. One of the first processes of programming. That's kind of what you want to be able to do. I think this is what's going to happen, and then I test it. So that's a good. If you just guessed, that would have been perfect. Perfect guess. Excellent. What does the following print to the screen? This one would be an error. Why would this one be an error?
That was the reason for last time.
Or actually, is this one an error? When I take it back, this one is not an error. This is not. I take that back. Because these guys are backwards. In this case, Joe is the pointer, right?
Mhm.
So we're looking at Joe. Joe used the dot operator. Didn't I say pointers use the arrow though? Except we also talked about the fact that the arrow is this the dereference here. So the arrow is the exact same equivalent as that. So when you say star Joe dot, that's the same thing as saying Joe arrow. Those are the 2 identical operators. The same thing for Jack. Jack is actually the object instead of dot operator is correct. So there'd be no error there. It would say Joe 10. Number 3. What does the following print to the screen? So if somebody said Jillian in the garbage, yeah. Actually, let me just go look at something real quick here.
That was an error.
So this would be an error.
This one gave us
You see how the name up here is private?
Yeah.
Can't access the name this way. When it's private. If you had said garbage, I would have given you half credit though. Because garbage and error give you half credit for the opposite sides. Error because it's the name is not public, you can't access a public or a private member variable from outside that class. These guys are the public modifiers.
If you were able to access it and just say garbage.
No, if you were able to access it, it would say garbage in that, yeah. So if you're able to access it, it would say garbage because this would be Jillian. And what's the name before? Garbage because we've declared that item, but we haven't put anything inside of it. That's good. Other questions? Okay. This is another one of these guys. Kind of how do we solve these problems? I like this one actually. This is a fun one. Baseball, soccer, and something else. Does anyone know the answer to these? This one?
Yes.
All right. So. So let's go through this real quick, and we'll look at all these guys here. We'll see what happens here. The first thing that I'm going to be noticing here is that I have this Teams pointer that starts off pointing at nothing. I pass the nothing into baseball. I don't know what baseball does, and then I get Teams back, and then that Teams goes into the next baseball. That Teams goes into the ice hockey. That Teams goes into the baseball. So we can see that Teams, every line Teams is being reassigned. So Teams is changing every line is one of these things that we were able to tell. And then when we get back down to here with the printfs, we'll notice that we're not reassigning the Teams, we're just using the Teams. So baseball and ice hockey are modifying that Teams pointer in some way. What are some reasons why you would modify a pointer like this? Anyone have a guess? This is how you create linked lists in C. And if we go through the code, we'll find out, I believe that's what this program is, a linked list. I think the other one's a vector, but they're the same thing. So we look at baseball, which is the first one. What we do is we create a runner. The runner is new. It's a more memory that we had not allocated before. We set its values to those things. We find out whether or not the cap, which is also the head. If you know 320, this makes a lot more sense. The head pointer, the cap, is null, means that there isn't one yet, so we return the new linked list. Otherwise, we create a new linked list and we push everything down the way. That's what that does. If you want, I'll go through all this line by line. Probably it'd be better to do it in office hours, but I can do it all here. If we look inside of the struct here, the soccer, we have what it does is if we have 0 here, if the goal is 0, that means if the item that we're trying to find is 0, we return the current item. Otherwise, we return the next item in the list by reducing the goal here. So the way that this works is this is a recursive function. This pointer points to a list of things, and goal is going to be decrementing each time until we get to that element of the list. It's a 0-indexed linked list, the same way we have a 0-indexed array. This is almost a complete implementation of a linked list, singular linked list. So if you don't understand it, this is what you end up with, and this is the reason why I suggest you draw pictures for these when you solve them. What's going to end up happening is when you have this struct mystery Teams here, starts off if we don't know anything, teams will be pointing at what? Null to start. So we know that teams just points at nothing. So I won't make a point at anything. After baseball, teams is going to be pointing at a single element of this struct. This struct consists of two parts. The struct consists of two parts, the integer and another struct. So this struct is currently pointing at null if we follow it, and we also know that this foo is the value. I don't remember what the first baseball function puts in it though.
3.
So the first value is 3, and the second, this is null. If we do it again with the baseball again, I don't remember if we put it on the end. Do we put it on the end or we put it in the beginning?
Yeah.
I think we put it on the end.
The new one?
Yeah, the new one.
The beginner, right?
Let's go. Let's look. Let's go look at the code. So we know that the teams in baseball is going to do something similar. It's either going to put this on the beginning or the end. We can figure it out here. The first thing we do is we construct a runner.
At the end?
We construct this runner. What was the second value? 2. So the 2 goes there. This gets pointing to null. Is the cap null or is the head null? Is teams null? No. So we come down here. So this at bat is equal to the cap, and so we start at the beginning here with the at bat. Points there. While cap dot bar equals null, does not equal null. Yeah, so we put it at the end. So we find out to see if this thing equals null or not. Does this equal null?
Yes.
Yes, it does. So what we do is after we find that, then we set the cap dot bar, which is this guy here, equal to our new runner, which is this one here. So we stick it on the end. So this guy here points to that. Like so. If we did this again with another guy, what would happen is we would create another guy out here, and that would point to the end and create this here with another value, whatever value we put there. This problem will probably take you the most time for the entire test. It probably won't be as hard as this one. The other one was slightly easier than this one, but the actual test is slightly easier. Ice hockey, what does ice hockey do? It deletes the first one. Okay. So ice hockey deletes the first one. So the way I know it deletes the first one is I come up here and I look. I see that puck is the value is what teams is currently pointing at, so puck and teams are the same. If puck is not null, so if teams exists, we hit the goalie, becomes the next one. We free the current one, and we return the goalie. So what ends up happening is we get a new guy here, which points to this one over here, which is going to be the goalie, keeping track of where the rest of the stuff is. We free this one here, and then we return the goalie. So when we return the goalie and we reassign teams down here, and we say teams equals ice hockey, teams will point to the new goalie, which is this one down here. So ice hockey deletes that first one. Baseball teams of 1, which means we stick another 1 on the end. Then we say baseball teams of 0, which means we stick a 0 on the end. Like so. Ice hockey of teams, which means we delete the first one. This guy goes away.
Isn't there a special case for baseball 0?
No. So that was the return case, which is soccer. Soccer has soccer of 0. It's a special case. And it's not, it's the second argument. You're correct with the second argument. So now we have this 1, 0. I'm going to pull these over to the left so that we can see a little bit better. So now teams points at 1, which points at 0, which points at null. We do 3, 2, which means that we add a 3 on here. And then we add a 2 on here, like so. So the process of solving this problem is we figure out how the first one works, how the first function works. We implement it, we iterate it. The second function, what does it do? We implement it, we iterate it. We just keep processing through it each time. Soccer returns the element. So this is index 0. This is going to be index 1. So we're going to return 0 for that first one. So the printouts will be 0, because that's the first index. The second index is 0, which is the value of 1. 0, 1, 2, which is the third index. 0, 1, 2 right here, which is 3. And then we do 1 again, which is 0, 1 here. Oh, we did ice hockey. Huh? Sorry, we did the ice hockey in the middle, didn't we? So we get 0, 1, we do the ice hockey, which moves this pointer around, just like so. Then we get the 2, which is 0, 1, 2, which is the 2, and then we get the 1, which is 0, 1, which is 3. So 0, 1, 2, 3 is the answer. Yes?
Is this how you'd actually write a linked list in C, or is this just terrible? So that
This is an actual implementation of a linked list. It's not fully functional, but it doesn't have all of the checks you might want, but it is. It's a singly linked list. I wouldn't use these names, obviously.
Wouldn't it be better to put all of this inside of a struct that is a linked list?
Not necessarily. Yeah. So the linked list is the struct, and the struct is a linked list. So a linked list is either a null terminator or a linked list element. That's all a linked list is.
But you wouldn't have another layer of abstraction between the node and the...
I would not know.
Oh, okay.
Some people like to do that. I don't particularly like to do that. And the reason why is, yeah, I think it obfuscates what's actually happening, which you might want sometimes. If you want that obfuscation of the other layer, if you want to hide it, if you want to encapsulate what's underneath it, that's fine. It also makes it harder in C. Okay, you got 15 minutes. Print the following politically correct holiday, treat it standard out. Pick the language. Echo would be pretty good. It'd be pretty easy. How many lines would you have?
4.
4 echoes with an X on each one. I like that solution. It's probably the easiest solution to do. I didn't actually come up with that solution the first time I did this problem. So when I saw the answers, I was like, shit. That was entirely way easier than I expected it to be. But yeah, so that's why it wasn't on the last second final. Such is life. Hi. If we did this with C or C++, we'd have a for loop of some kind or a lot of printf statements, which would also work. But the echo, I think, is the easiest one. Number 2. Find and delete all the files in the current directory only that contain the string included in them. Print nothing. Bash, right? So how would you do that? You'd grep for the word include, right? Then what would you do? You have some sort of loop inside of them. Let's see if we can come up with that loop. I would do something like this, for f in grave, so this would be a grave here, grep, pound include in the current directory like this, do rm $f and, or done, sorry. Think so? That would be the complete loop. If you wanted to use the $sign in the parentheses here, that would also work. It's another version of it. If you saved it to a variable and you said for all these things inside this variable, that would also work. If you realize that you actually also need a cut on this because it also includes the file name and the output, you can put a cut there as well. If this is the only part that you had, you would get 100% credit though. If you only had the grep, you'd get partial credit. If you had the for loop without the grep, but you had something else inside there, you'd also get partial credit. I'm not looking that you memorize all the different parts of it. I'm just looking to see that you know the concept of the fact that you want to do a grep and a for loop. if you'd done a for loop and a grep and you didn't know how to put the two of them together, that would have been most credit. Particularly if you'd had the cut in there, if you had the grep with the cut, I would have given you almost whole 100%, probably 9 out of 10 on this one. Even if you didn't know how to connect the two of them, because that's the hardest step. Any questions about that? Yeah.
So that there is full credit or ghost credit?
This area would be full credit.
Okay.
So if we grabbed to do a variable and then variable, that would have been.
That would have worked as well. So you did something like this where you said files equals with the graves,
Yeah, and then 4 in files.
4 in files. That would also be full credit. That's also full credit.
You still need a dollar sign on the remove?
Yeah, you need the dollar sign.
I
on
mean,
the
on
files.
the remove.
The F here, yeah, because the F is that guy there.
Okay.
If you just said RM files instead of the for loop, that would have been partial credit because unless you had done the cut correctly, the RM doesn't know how to do that.
If we do the cut, if we do the cut, the field that we choose, does it matter if it's arbitrary?
No. If you just guessed, if you said I think it's this one, that'd be fine. You know that the cut's supposed to be there. Because those are all things that you shouldn't know. Not necessarily. I mean, you might know them because you've done the cuts so much in the grep, so you might know what all those fields are exactly. I don't expect that you would know those. If you just said, I know I have to do a cut here, if you did a cut with a partial thing, you did a little comment there that said, this is supposed to be there, but I can't figure it out, that's also fine. So the concept is, can you figure out how to kind of cobble together the program without having access to the computer for both of these is really the way that you want to think about it. Any more questions? Good. Oh, so this one, if I give you C code to finish, I probably won't, simply because there isn't enough time to do this on the test. Usually, if I can't get through an entire test explaining it to you before I give you the midterm, that means I can't give you all those questions. So this would be too long. So that's the reason why the first midterm we went through was cut off at the first section above, and this part after this would be cut off for the real midterm. If I give you anything like this, it would replace the section above where you'd be programming blind, versus here you get some information. I prefer the programming blind with no extra information because I'm asking you 2 questions. One is, have you thought about what languages it is, and do you know how to actually implement anything in those languages? These guys here are a little bit more difficult. So I'm not going to ask you these questions below. If you want to know the answers to them, come talk to me in office hours. I will have extra office hours tomorrow. I will be somewhere on the 4th floor from, say, 2 o'clock to 5 o'clock. Okay? So if you guys want to come talk to me and ask me about tests, questions, and programming, I'll answer pretty much any programming questions you guys want to know. From 2 o'clock to 5 o'clock tomorrow. Yeah?
Is our languages aren't there going to be on a test?
No, definitely not. I never ask the same question. They're always going to be a little bit different. Usually one of the ways you should look at it is you should think about, when you look at this, usually the way I do it is I say, so if you look at this practice and the actual test I gave last semester, you'll notice that most of these multiple choice, or some part of these multiple choice, got turned into free response questions, and then vice versa. The other part of it is you should expect that any of these conceptual questions, because these are really conceptual higher level questions, should be able to be asked in free response form, vice versa. The coding questions are going to be pretty similar to the existing coding questions, but I'm not going to ask you the exact same thing. I'm going to ask you something similar to it so that you can understand the concept. And then the free response coding questions are probably going to, there's that one question that's going to be the hardest one, which is, can you program or understand somebody else's program without any identifying factors? If you've ever had a question, if you've ever said, why do I need to name my variable names correctly? This is exactly why. The mystery stuff is going to drive you crazy. So, yeah, that's typically how I do it. Other questions?
Are you still going to post the solutions or not?
I do. I will. Other questions? All right. Yes. Yeah. So this might be super annoying because our brains is flickering on the screen, but such is life. So if you don't know what Cheat Engine is, Cheat Engine is a general purpose memory hack It allows you to inspect and then modify another application that's running memory. So these are all the school's computers have are what they call deep freeze or whatever, deep frozen. So as soon as you restart it, it starts over from scratch. But you still can't install anything on